Hello everyone, today we're going to be talking about the properties of limits. Our definition says, let b and c be real numbers and let n be a positive integer. And so we have three new properties of limits that we're going to be talking about today. The first property tells me that when I am taking the limit of a constant, b, the limit will always be that constant regardless of whatever c value I'm approaching. So if we want to see this visually, let's say this is my XY axis, and let's say I'm taking the limit of the constant 5. Well, I know that graphically, this means that I have a constant, passing through the value of 5. And regardless of which C value I look at this limit from, let's say I'm approaching this C value from the left or from the right, the limit is still going to be 5. If I choose this C value from the left or from the right, the limit will still be 5. So that is why anytime that I take a limit of a constant, the answer is always the constant. Okay. Now let's say I'm taking the limit of x, and I observe this limit as x approaches c. Well, the answer will always be c. And again, if I want to observe this graphically, let's say I have this graph right here of my XY axis. And I know that X is a line, specifically the line with just a 0 y-intercept and slope of 1, right? This is my function here. Now, let's say I'm observing this function of X, and as x approaches 1, because my function slope is 1 over 1, the limit as I approach 1 on the x-axis is going to be 1 on the y-axis. Same for 2. If I approach 2 on the x-axis, my limit will be 2 on the y-axis. And this will continue for all values of x on a line. If I observe 3 on the x-axis, my limit is going to be 3 on the y-axis, etc. Okay? And lastly, I have the limit of x to the power of n as x approaches c would just be c to the power of n. And I'm going to draw one more example. If I were to have my xy axis here, I know that a cubic function looks like this, right? And so let's say I'm observing the limit of my function x cubed, and I observe it at 1. Well, I'm going to be observing 1 cubed, right? So I'm just going to be cubing whatever that constant is that I'm observing. Okay, so these are my three properties, and we're going to go ahead and observe what these look like at the following values. So it says evaluate the following. We're going to start with the limit of 25. So again, this is my first property that tells me that whenever I have the limit of a constant as x approaches any number, and I think we had the notation here was b, so I'm going to keep the same notation. So regardless of what c value I approach, my answer is going to be b. So even though this is telling me x is approaching 100, because I'm observing the limit at the constant of 25, my limit is just 25. Now, here I have the limit of x as x approaches -5, and my property tells me that if I take the limit of x as x approaches c, my answer is just c. So because I'm taking the limit of x, my limit is whatever my c value is. And in this case, my c value is -5. Okay. Moving on to my next problem here. I have a power of 3. So if I am observing the limit of x to the power of n as x approaches c, my answer is c to the power of n. So here n is 3 and c is 3. So I'm going to take c, which is 3, and put it to the power of n, which is also 3. And 3 to the power of 3 is 3 times 3 times 3, which is 27. Okay. Now, let's go ahead and move into some of these other functions. So I have the limit of 5x squared plus 10 as x approaches 2. So all I'm going to be doing here is plugging in 2 into my x. So I'm going to say 5. Instead of x squared, I have 2 squared. 2 squared I know is 4. And 5 times 4 is 20, plus 10 is 30. So my limit here is 30. And I know some people might be tempted to say, oh, the limit equals 30. This is improper notation, okay? So remember, the limit, when we take the limit, it's an action, and I can't have an action equal to a numerical value. That doesn't make sense. So if you are tempted to write something on the left side of that equal sign, you would have to write the whole problem. That would be proper notation. But you can't just write lim. Lim equals 30. That is incorrect. Okay? So, moving on. I have the limit of a function to the power of 2 as x approaches 3. So, same thing here. I would plug in my x of 3 into the function and then just square it. So, I'm going to go ahead and take my function, 3x, and I'm plugging in 3 for x, and then I get 9, and then don't forget this whole thing is squared. So 9 squared is 81. Okay. Now I have another case of a limit of a constant as x approaches c is still the constant. So here my constant is 10. So even though they're trying to trick us with this pi, I know my limit is still going to be whatever constant I have, which is 10. Okay. Here, I have one of those function and approaching a value of that function. So I plug in this value of 3 anywhere I see x. Okay. So let's go ahead and do that. I'm going to get 3 squared plus 3 over 3 plus 2. 3 squared is 9. 9 plus 3, 12 plus 3 is 15. And 15 divided by 5 is 3. So the limit of this function as x approaches 3 is 3. Okay, sine. Here we go. Some fun ones. So I'm going to be plugging in my x value of pi over 4 into my sine function. So I'm taking the sine of pi over 4. If you know and have your unit circle memorized, then awesome. You can use your unit circle. If you don't have your unit circle, I know that pi over 4 converted to degrees is 45 degrees. So really, I'm taking the sine of 45 degrees. And I know that a 45-degree triangle, if I want to use reference triangles, looks like this. So to take the sine, remember that sine is, opposite over the hypotenuse, which in this case for a 45-degree angle would be 1 over radical 2. We rationalize, and I end up with radical 2 over 2. Okay? And again, if you know your unit circle and you automatically knew that the sine of pi over 4 is radical 2 over 2, more power to you. If you forget the unit circle, remember you can always use reference triangles to evaluate these. I have tangent of pi over 6 for my next limit. Again, if you know your unit circle, amazing, use it. If on the AP exam you forget your unit circle, you can always use reference triangles. So I convert this to degrees, and I know I'm going to be observing the tangent of 30 degrees. And a 30-degree triangle using reference angles would look like this. And so tangent is opposite over adjacent. And in this case, opposite is 1, adjacent is radical 3. And of course, we always rationalize. I can never leave a denominator with a radical. So to get rid of the radical, I multiply by the radical over the radical. And I end up with radical 3 over 3 as my answer for this particular one. Now, these are some more simple examples of how I can evaluate functions numerically, right, using the properties of functions. But we have a couple other properties of functions that I want us to get into. So our notes here say, let b and c be real numbers, and let n be a positive integer, and let f and g be functions with the following limits. So I know that the limit of f of x is L, and the limit of g of x is k, okay? And so our first property here that we're going to be going over is a scalar multiple. A scalar multiple tells me that if I have a b that I can factor out of f of x, I can factor that out completely from my limit. And then I take the limit, and if I know that the limit is L, at the end I can multiply b times whatever answer I get for my limit. So really just factoring out a constant. Sum or difference. This is telling me that if I am taking the limit of f of x plus g of x, I can separate these two limits separately. So I can first take the limit of f of x and then add it to the limit of g of x. And then simply, of course, add their limits at the very end. Product, very similar. If I'm taking the limit of f of x times g of x, I can choose to instead take out the limit of f of x and then multiply it times the limit of g of x and simply multiply their limits at the very end. Same goes for if I'm dividing or taking the quotient. I can take, if I'm taking the limit of f of x divided by g of x, I can take the whole limit of f of x and divide it by the entire limit of g of x. And then I would simply need to divide those numerical answers at the very end. Power. Instead of taking the limit of f of x to the power of n, I can take the entire limit of f of x and apply the power of n at the very end. Okay, so kind of just deconstructing limits to make it a little bit more digestible. Okay, let's go ahead and get into some of these problems. So for numbers 1, 2, 3, and 4, they give me my functions of f of x. My function of f of x is 2 radical x plus 3. My function for g of x is 5 radical x minus 4. And I need to use these equations to evaluate the following. So for the very first example, I'm going to be using my product property that tells me that instead of taking the limit of f of x times g of x, I'm going to find the limit of f of x first and multiply it times the limit of g of x afterwards. Okay, now the limit of f of x, what's nice is that I know this equation already. For f of x, my equation is 2 radical x plus 3. And for g of x, my equation here is 5 radical x minus 4. And so to find the limit, I just need to substitute 8 in for x. Okay, so that's what I'm going to do here. I'm going to take my function. Oops. Take my function, and I'm going to be substituting 8. And I'm multiplying this times g of x also as I substitute 8. And so here I have two binomials. I'm going to use FOIL or the box method to multiply. I'm going to use FOIL because I prefer FOIL, but you can also use the box method if you prefer. Okay. So FOIL, I multiply first 2 radical 8 times 5 radical 8. So 2 times 5 gives me 10. And radical 8 times radical 8 is radical 64. Okay. Outer, I'm going to multiply 2 radical 8 and negative 4. So I'm going to get negative 8 radical 8. Inner, 3 times 5 radical 8 is going to give me 15 radical 8. And last, Positive 3 times negative 4 is negative 12. Okay, so I'm going to go ahead and simplify a little bit. I know that the square root of 64 is 8. And so 10 times 8 is 80 minus 12. And then negative 8 radical 8 and positive 15 radical 8 are going to give me 15 minus 7. 7 radical 8. Yeah. And I can combine 80 minus 12 is going to give me 68. So my final answer here is 68, 7 radical 8. However, I can also simplify my radical 8. I know radical 8 is 2 radical 2. So 14 times that 2, 7 times that 2 is 14 times radical 2. This is my final answer. And again, as a super quick review, my radical 8, I simplified because this is the same thing as radical 4 times radical 2. And my radical 4 is just 2. So I get 2 radical 2 times the 7 is what gave me my 14 radical 2. Okay, moving on to number 2. So here I have the limit of 3 times f of x. And this is where I can use my scalar multiple property. And I'm going to factor out my 3 outside of f of x. Okay, so it's going to look like 3 times the limit of f of x as x approaches 25. So all I'm going to do is I'm going to first focus on finding this limit. Then I'm going to worry about multiplying times the 3. Okay, so again, my function of f of x is 2 radical x plus 3. And instead of x, I'm plugging in 25. So in here goes 25. Okay, so 2 times the square root of 25 is, the square root of 25 is 5. So 2 times 5 is 10 plus 3 is 13. But remember, I still need to multiply by that 3. Okay, so at the very end, I still have 13 times 3, which is 39. And that's going to be my final answer for this limit. Okay. Moving on to number 3. And I'm going to erase some of this up here so it looks a little bit cleaner. Okay. So I'm taking the limit of g of x divided by f of x as x approaches 16. So I'm going to do this separately. I'm going to first take the limit of g of x as x approaches 16, plugging in 16. Then I'm going to take the limit of f of x as x approaches 16, plugging in 16, and divide them each, okay? So I'm going to find first the limit of g of x. And my equation for g of x is 5 radical x, okay, minus 4. And I'm going to evaluate that at 16. So instead of x, I'm plugging in 16. Okay, and that's going to be divided by the limit of f of x. And also at 16. Okay, so let me zoom in a little bit. There we go. So now I'm going to go ahead and evaluate these. So 5 times the square root of 16. Well, the square root of 16 is 4. And I have 2 times the square root of 16. Again, the square root of 16 is 4. 5 times 4 is 20. 2 times 4 is 8. 20 minus 4 is 16. And 8 plus 3 is 11. I can't simplify. I don't need to rationalize. So that is my final answer. Okay. Here we go. I have the limit of f of x minus g of x as x approaches 8. And same thing, I'm splitting these up. I'm going to take the limit of f of x as x approaches 8, and I'm going to subtract by the limit of g of x as x approaches 8. I'm plugging in 8 into each of these. So starting with f of x, my equation for f of x is 2 radical x plus 3, but I'm plugging in 8. And this entire thing is going to be subtracted by g of x, plugging in 8. And remember, we talked about how the square root of 8 is 2 radical 2. So that's going to come in handy. I don't need to simplify again. I already did that the first time, right? Let me go ahead and simplify now. So 2 times 2 is going to give me 4 on the outside of my radical. 5 times 2 will give me 10 on the outside of my radical. There we go. And before I begin to try to add and subtract these values, let me distribute this negative sign to both of the values in my parentheses. So the left side remains the same. But on the right side, I'm going to have subtraction of 10 radical 2 and addition of 4, because negative and negative on that 4 give me positive. Now I can go ahead and combine. So I can combine here my 4 radical 2 and negative 10 radical 2. And that's going to give me negative 6 radical 2. And then I can combine 3 and 4 to give me 7. So my final answer here is negative 6 radical 2 plus 7. Okay, got 2 more of these. We're almost done. So here I'm going to use the power property that tells me that I can take the limit of g of x and at the end apply my power of 2. So let's go ahead and take the limit of g of x as x approaches 12. 12 first. So, whoa, what happened? Here it is. Okay. So the limit of g of x as x approaches 12. Well, my equation for g of x is 5 radical x minus 4, and I'm plugging in 12. I do need to simplify my radical 12. So radical 12 is the same thing as radical 4 times radical 3, and radical 4 is 2. So I have 2 radical 3. So this is going to become 2 radical 3. And I'm going to get 5 times 2 is 10 minus 4. And now I have to take this entire equation of 10 radical 3 minus 4. And here is where I apply the square. And again, this is going to be like a binomial situation. So I'm going to have 10 radical 3 minus 4 times 10 radical 3 minus 4. And I use FOIL. It's not enough. I repeat, it's not enough to just square this guy and subtract the square of 4. No. You have to take the entire expression and multiply it times itself. Okay. Now, when I use FOIL, it's going to look like 10 radical 3 squared. And you know what? Let me go ahead and move this up because it's going to continue going. So let me create a division. Here we go. And this is going to be 10 radical 3 squared. Okay. That's my front. My outer is negative 40 radical 3. My inner is negative 40 radical 3. And my last is positive 16. So 10 radical 3 squared is going to give me 100 radical 9. My negative 40 radical 3's combined are going to give me negative 80 radical 3. And plus 16. And then I know that the square root of 9 is 3. So 100 times 3 is going to give me 300 minus 80 radical 3 plus 16. I can combine my 300 and my 16 to give me 316. Okay. And then I have minus 80 radical 3 as my final answer. Okay. Last one. Here we go. I'm going to take the limit of each of these functions individually and then add them at the very end. So I'm going to take the limit of g of x and the limit of f of x and then add those two answers. So the limit of g of x as x approaches 18, well, I'm just going to plug in 18 into my equation of g of x. And then for f of x, same thing. I take my function of f of x and I plug in 18 to find the limit. And then I'm going to add these two values. So I'm going to get 5 radical 18 minus 4. And you know what? Let me go ahead and simplify radical 18 while we're at it. So radical 18 is the same as radical 2 times radical 9. And radical 9 is 3. So this is the same as 3 radical 2. So here I'm going to have 5 times 3 radical 2 minus 4 plus 2 radical 3 radical 2 plus 3, okay? And I can multiply. 5 times 3 is 15. 2 times 3 is 6. And let's go ahead and combine like terms. So my 15 radical 2 and 6 radical 2 are going to give me 21 radical 2. And then negative 4 and positive 3 will give me negative 1. So that is also my final answer. Thank you all so much for watching. Let me know if you have questions.